So in question number 2, the manager sampled 100 sick days, and the manager is interested in whether age group is actually a factor in the number of sick days taken. One thing that's actually given to you here is the proportion of labor force. So 30% of all your employees are guys in their 20s, 40% of all of their employees are in their 30s, and so on and so forth. Based on this observed frequencies, is there evidence that sick days is related to age group? Now, just to drive the point across here, how to observe something like this, guys, where of the 100 people sampled, or 100 sick days sampled, I see like 50 people from the guys in their 20s and 40 guys from the guys 50 and over, and I only see 5 and 5 for the people in their 30s and 40s. Wouldn't this indicate that age is a factor? In spite of 30% of the population being the guys in their 20s, out of 100 sick days sampled, we've observed that 50 of them were taken by these younger guys. And these 40 sick days were taken by these older guys. Okay. So the more the number of sick days departs from these proportion of labor forces, the more evidence we have in favor of sick days or age being a factor in affecting the number of sick days being taken. So let's formulate a null and alternate hypothesis here. You guys use one. The null hypothesis is that age is not a factor. Okay. Age is not a factor. Okay. Mathematically, we can state it as, let's call this 1, 2, 3, and 4 groups. The probability that the number of sick days being taken by the guys in their 20s will be equal to 30%. The probability that the number of sick days being taken by the guys in their 30s will be equal to 40%, reflected here. It will be equal to the proportion of your labor force, and so on, 20% and 10%. Should this be the truth, then we can conclude that age is not a factor. If age were to be a factor, then we would expect at least one of these probabilities to be different from the hypothesized value. Okay. So to conduct this test, what we're going to do is we're going to conduct the chi-square goodness of fit test. If the null hypothesis is true, out of the 100 sick days sampled, I would expect n times p1 number of sick days taken by the guys in their 20s. I would expect n times p2 or 40 sick days being taken by the guys in their 30s, and n times p3 or 20 of the sick days being taken by the guys in their 40s, and finally the last frequency will be 10. The more these numbers the more these observed number of sick days departs from the expected frequency, the more evidence we have against the null in favor of the alternate that age is a factor. Well, how much evidence is enough evidence? We have to compute a test statistic, the chi-square test statistic, which is given by this. So again, the numerator, guys, captures the deviance or the departure of the observed frequencies from the expected frequencies divided by their expected frequencies. Let's see, and I'll let you guys compute that. If I compute it, I get a value of 2.46. And the next thing obviously I'm going to do is compare that against some kind of chi-square test statistic. So the critical value here is the value of chi-square such that that right tail is equal to your significance level of 5%. We have 6 categories in our table. So our degrees of freedom for chi-squared will be k minus 1. So that will be 3. So our chi-squared critical value would be equal to chi-squared sub 0.05 with 3 degrees of freedom. Go look that up, guys, and you're going to see that it's going to be 7.81. 7.81 is to the right of our test statistic, where our test statistic does not lie in the rejection region. Therefore, we failed to reject the null hypothesis. Okay. So there's no evidence suggesting that age is a factor. And if we eyeball the data again, guys, compare that versus that extreme example I gave before. If you compute a chi-squared test statistic for this, had these been the number of observed sick days, I'm going to bet that you're going to get a test statistic or chi-squared observed that's going to be pretty deep in the rejection region. But this data set here, okay, doesn't depart too much from the expected frequencies, right? Okay, and our chi-squared test statistic reflects that. It doesn't give us an extreme value. It gives us a value that is not in the rejection region. Therefore, we failed to reject H0. There's no evidence that age is a factor when it comes to sick days.